Good morning. This is Zach Zaharowitz of the Lighting Quotient, head of the applications group, with Paul Ford, our vice president of product design. And this morning we'll be presenting the webinar on the new S14X series covering the S141, 142, and 143. Before we get started, two housekeeping items. If you hover near the top of the screen with your mouse, you should get a drop down that will include a Q&A selection. And that'll give you a box that you can type questions in. So feel free to make use of that, and time permitting at the end of the webinar, we'll go through that information, see if there are questions, and try and answer those. Also, we will be exiting or stopping the video of ourselves, although we will come back on at the end of the presentation because we do have some samples here we can hold up to the camera and present. But just to keep the quality of the PowerPoint show up, we're going to go off camera during the presentation. So with that, I'll turn it over to Paul.
Thanks, Zach. This is Paul Ford, VP of Product Design at Lighting Quotient. And I'm going to go through the PowerPoint with you, but I'm going to, as Zach said, I'm going to turn off the video just so the bandwidth is a little better. And so we'll get started with that. Thank you. So today I'm pleased to talk to you about our new product, this product family. It's the S14X, we're calling it, which is the 141, 142, 143. It's a new expansion to our product line, which you could think of as a surface-mounted version of our 222, 3, and 4, where you can't recess the fixture. Similar to the 144, which is a linear product. The 141 is an 8-inch unit nominal. 142 is a 16-inch unit, and the 143 is 21 inches long. The same cross section, low profile. I'm going to show the cell sheet is a two-sided sheet, which is on the screen now. The 141, 2, and 3 are shown relative sizes to each other, next to each other on the front. And on the back, we have features and benefits. We have a cross section through the fixture, as well as a thumbnail showing the performance and images of the pendant cantilever options. If you take a closer look at the cross section, you can see that there is a hinging lens, which is new. The baffle can go internal to the lens, which is an option. And we have serviceable light engines and a new precise beam shaping optic inside. Another nice feature is that it is an integral driver unit, so there's no remote drivers that you have to deal with. And on just showing side by side the scaled performance, you can see the 141, 2, and 3. Obviously, you're getting much more light with the larger unit. Looking at the catalog pages, which all of this information that I'm showing you and is online right now, so it is available on our website. The front page of the 141 shows an image of the product, as well as dimensions and features as far as specifications for finish and optical assembly, mounting. Thumbnail of the performance curve down on the lower right. The 142 similar, showing the 16-inch nominal unit, and the 143. On the back of the pages, you have different options for light output and light output and drive current, as well as mounting. And if you notice the accessories on the 141, we have a new cantilever, which is a VCM, which is a slightly smaller cross section, which was sized for that smaller unit, whereas the 142 and 143 have a larger cantilever. The other difference, the pendant on the single unit is a single stem pendant. On the longer units, we use a double stem pendant for stability. If you look closer at the styles for each one, the 141 has 9 LEDs, and they can be driven at either 350 milliamp or 700. We can also drive them at any drive current that you'd like under 700 with tunable drivers, which I'll get into in a minute. The 142 has 18 LEDs, so there's 2 light engines, and the light engines are serviceable. Up to 2,400 lumens on that at 40 watts. The 141 is either 10 watts or 20 watts, depending on the drive current, and then it jumps to 20 and 40 watts for the 142. And then the 143 is either 30 or 60 watts nominal. with as much as 3,300 lumens. Those numbers shown on the back of the page are based on 3,500 Kelvin 80 CRI, so it does go up and down depending on color temperature and CRI. All of the pages have a hyperlink where it says click here to open the scaled performance tables, which is very handy for looking at the light output efficacy by drive current, and as well as CCT, color temperature, and CRI. So you can see there is a difference between not only drive current, but the color temperature. Mounting codes, we have 3 mounting codes for these units. So C mount is a ceiling mount over a recessed junction box. If you can't get a junction box in, you can only poke through with conduit or flex. The S mount is ideal for that, so you can run conduit directly into the mounting plate. And then we have the X mount, of course, for pendant or cantilever. We're just showing the pendant in this view right now. Finishes, we offer standard finishes of semi-gloss white, which is 02, and the 22, which is the matte white. We also offer custom or RAL colors. So any of the RAL colors, or if you have a sample chip that you want to send in to us, we can get that computer matched. Voltage driver options, we have 120 through 277 volt options, and now we also have 347 in both non-dimming and dimming. And on the pages, all of them have a link to this MA1303, which is very handy when you want to figure out which driver is going to be used based on the dimming code. So in this case, I'm just going to open up one of them in the ZX option, which is our 0 to 10. We'll open up the Universal Lighting Technologies page where you can get information such as forward voltage, and all the driver specs are available. Option codes, we have either a clear lens or with the lens and the baffle. And we also have an MRI option, which is ideal for wall washing in MRI suites because the fixture is all aluminum. There's no ferrous material. The driver is located outside of the MRI room, so it's a remote driver fixture in that case. And we do sell MRI filters for each of the drivers that enter into the room. They have to be sent through an MRI filter. This is an image showing the fixture with the baffle internal. The color temperature options are 2700, 3000, 3500, and 4000. And we have 90 CRI available for 2700 and 3000, and we have a 70 CRI option for the 4000K. And again, additional color temperature and CRI options are available. Just consult factory, but we do have minimum runs that we have to do for the boards. Dimming options include we have TE for for line voltage dimming, so it dims over 2 wires, and that's using a trailing edge or reverse phase or ELD type of dimming control. The ZX option is 0 to 10 analog dimming, and then we have 2 Eldo LED options, one of them 0 to 10. The Eldo LED is a premium driver which dims down to 0.1%. The Eldo LED Dolly is another option for Dolly dimming, and then we have 2 Lutron options. Now, depending on which fixture it is, this is the 141 page, so it's showing the Lutron as a remote driver because of the size and the shape of the Lutron drivers. They do not fit inside the small fixture, but they are integral on the 142 and 143. The L3 is for their Lutron Echo Bus dimming controls, and the LH is for the traditional 3-wire dimmed hot type of dimming. Accessories include the cantilever and the pendant and the MRI filter, which I mentioned earlier. And this is where you can really see the difference between the size of the cantilever and the 2-stem versus 1-stem pendant assemblies. I'm going to hand it over to Zach, and he's going to go over the website.
As Paul mentioned, all this information is live on the site. It was loaded the last week of April. So just to walk you through where various items are located, if you go click the products button, the quickest way now that you know the style numbers would be go go to the quick finder to get information on any of the 3 units. In this example, we're using the shortest unit, the S141. And at the top of the list of the available references is the data sheet. So that gets you the typical 2-sided black and white cell sheet that Paul already illustrated in some of the earlier slides. Underneath that is a collection of items called the product fact sheets. And those include the color cell sheet, which you also saw in a previous slide, and then other items like those scaled performance tables. So even though those do exist as a hyperlink on each cut sheet, if someone were to come in to the website and just see product fact sheets first, that's another way they can get at the same information. Underneath that, you'll see the lighting facts label, which is really the artwork of what appears on the catalog cut sheet. But if somebody wanted to scrutinize that in greater detail, it is available as a separate item. And then finally, the TM30 reports. And we've been including a short discussion on this in our more recent webinars. TM30 at this point still isn't officially adopted, if you want to put it that way. CIE and others are saying that they are reviewing it. Everyone, excuse me, seems unanimous in voicing that it does seem to provide more, excuse me, more robust color information than what we've been using in terms of the traditional color rendering indices. In this case, what we've done is generate for each of the color temperatures and CRIs a 7-page report. The spreadsheet that generates this from the photometric testing had 2 presentation formats, and while each was nice, each lacked some of the information that was in the other. So at the end of the day, we decided just to include both formats, which is a total of 7 pages. There is some redundancy, but what you see here on the first page is a spectral irradiance chart in the upper left corner. So here you have the sort of more linear charting of the reference source, and the more squiggly line underneath represents this particular LED source, the nominal 2700 Kelvin. In the upper left corner, you're seeing summary data, such as the 2742 actual tested color temperature. You see the fidelity index of 88, which is actually different than the old CRI, and I'll touch on that in a second. The RG is a gamut index, which is saying that if it's above 100, some colors are being saturated. If you look at the bar charts in the lower left, what you're seeing here is for 16 different hues that they've defined, what's the fidelity, meaning how faithful is it rendering various reds or oranges. So if it's below 100, it's some deviation from the reference source. The lower chart, if it's above the horizontal line, it's saying that color is being in some way saturated. If it's below the line, it's saying that particular color or hue is being undersaturated. And the bullseye diagrams to the right are trying to say the same thing in a different graphic format. Basically, where you see a color creep outside of the circle, that's saying relative to the reference source, that particular color is being saturated. So where you see the green creep outside, that's telling you greens are being somewhat saturated in this case. Whereas a color like the blue or cyan that creeps slightly inside the circle is being somewhat undersaturated. You see those bullseye diagrams repeated again on this page. Once again, you see this fidelity index of 88, the gamut or sort of saturation being slightly over 100. You see the traditional CIE-RA here of 92, and don't be surprised if the new fidelity number differs from the old CIE, because again, the CRI we've been using was based on 8 reference colors, whereas this new metric is using 99. So there are some inherent differences when you're scoring with many, many more colors. You'll also see the XY coordinates in this particular presentation. Moving on, there's another page showing where it lies in the black body curve. The spectral irradiance is repeated. And up in this corner, besides that RF and RG, which is the fidelity and gamut and the traditional CRI based on the CIE method, you'll also see R for R9 here of 70 for those interested in the traditional measurement of red, so to speak. And there's also a fidelity metric for skin, in this case 90, that's based on 3 reference colors that were specifically selected really to represent a variety of skin tones. That bullseye diagram or scatter shot diagram in the upper left here is showing for each of the 99 colors, how did this reference, or excuse me, how did this tested source, this LED source, compare against the 2700 Kelvin reference source. So in each case, you'll see one dot representing the reference source and one, this particular tested source. Here is a graphic representation of the 99 colors. And while this may not come across so clearly in PowerPoint, each of these 99 cells is split in half, and it's meant to represent on the left how the reference source would make that particular color look versus the test source, which is shown for contrast in the right hand of the cell. Here again, the 16 hues showing the fidelity and the gamut. That lower chart being the gamut, and is it above the horizontal line or below? Is it being saturated or undersaturated? And this is a quick pictorial of all 99 colors. So think of this as one massive scoring exercise across 99 colors in terms of fidelity. Moving along, there is a PDF of the ITL source. In this case, ITL not being independent testing lab, but in this instance, UL actually having done the independent photometric testing. So if you have a designer who actually wants to go through and see the nitty-gritty of the results of the report test, all that information is presented. And Paul will touch on briefly how that all relates to the TM21 information in just a few minutes. IES files are available for those designers or even your own application staffs who might want to do calculations. As Paul already pointed out, lumen output varies with the color temperature, the CRI selection, and the drive current. And rather than make someone have to go to those scaled performance tables, convenient as they are, and go through and factor one report for a different color selection, we've essentially used Photometric Toolbox to create duplicate reports representing each CCT and CRI selection as well as the drive current, just to make it a little more easy. If you know your client is interested in a specific selection, it allows you just to download that one file and then get on with your calculations. For any clients you might have using BIM, and in this case specifically Revit, there are face-based objects available on site. The face-based is something that an architect using the architectural package can insert it into the model, as well as another designer, lighting designer, or electrical engineer using the MEP package, who may not have the full architectural file, can still use these objects and place them in the appropriate positions within the design. So those are also available as a zip file. And finally, next to last, there's one more item, the installation files. And we get asked for these often, not so much strictly just from the installation standpoint of a contractor wanting to know, but frequently designers wanting more information to evaluate which mounting might be more compatible with their particular project. So those will range from things like the C mount, which is designed to go over a recessed outlet box and provide a large enough hole for inspection of a splice in a J box, whether that's new or you're placing this unit over an existing J box. The S mount, which can be fed directly, and you essentially use the volume within the fixture, which is adequate to do the splice within the fixture and without the need for having that recessed J box. The accessories are also represented, in this case, an example showing the cantilever mounting. And there are also pages dealing with light engine replacement, driver replacement, and even down the road in the future of this fixture, disassembling it and then using a live link that gets somebody information on where are there locations around the country where there are recycling centers that would be capable of handling these materials, probably most typically the aluminum and the metal. Finally, I jumped the gun in saying finally, before the configure it. This gets you access to the configurator with which you as agents would also have visibility of the pricing. For this example, because we post the webinars later, we're using sort of the generic version rather than the rep portal. And in this case, you're not seeing the pricing exposed. So even in the case of a designer, they could use this feature, go through each of the mounting codes, finish codes, voltage code, and make their specific selections, whittle it down to what they need, use the notes box to add specific comments that they might want to either remind themselves, or in passing this along to the architect, you may want to note certain features. And then go over to the left, select Cut Sheet, which will let them fill in the project name and the type designation if that's been determined. And then essentially generate a customized sheet, once again representing the project name, type, any specific notes they added, and that same information then repeated on the specification side or page 2 of the cut. Moving back to the performance, Paul will take you through the photometric testing and how that relates back to the LM80 data from the chip manufacturer and our TM21 information.
Okay. I'm going to go through a little bit more detail on the photometric report. This report was done by UL Photometric Services. This is our S14X, which is the middle-sized fixture, the 16-inch nominal with 18 LEDs. This particular source was tested with 4000K 70 CRI LEDs. And we also have tests on the other sized units in the 2700 and with 90 CRI. The first page is just a title page and then a table of contents. The third page is where you start getting into the integrating sphere as well as goniometer tests as far as total lumens out, the efficacy, the CRI, as well as the color temperature, and electrical data. They test at 277 volts. So if it's a universal driver, which nearly all of our fixtures, all of our LED fixtures are now universal voltage, they will test worst case for the electrical at 277 volt. So we get the THD and the power factor and things like that will show up. On the next page shows a little more detail on the color of the color aspects as far as CRI, CCT. They have not adopted the TM30 yet, so that hasn't been added, but I hear that they are going to start adding that to this page in future tests. But this is where you can get your color coordinates in either X, Y, UV or U prime, V prime. The DUV is actually the distance away from the black body curve, so you can see the black body curve running through. This particular 4000 Kelvin is highlighted in yellow is the standard ANSI bin, and the bullseye below is showing the distance from the black body curve, which in this case was 0.0027. And then at the bottom you have your spectral power distribution curve over the spectrum. The next page shows a candle power curve showing the asymmetric distribution for this wall wash unit, as well as the current THD and power factor and things like that, as well as zonal lumen summary. And then the final page of the photometric report is the candela tabulation. Next, I want to touch on the LM80 data. In the point sources are a little different than the linear product. The linear product, because of its size, we're using mid-power LEDs. In the small units, in order to get the punch and be able to space them on center, we're using high-power LEDs. They are the Lumiled's Luxeon ZES emitters. So the emitters themselves are tested by the manufacturer. In this case, they're tested at, they actually tested at 4 temperatures. I'm showing 3 of them. They test at 55, 85, and then they also test an additional at 105 and 120. And this chart is showing the average light output at 0 hours all the way up to 10,000 hours. And the reason 6,000 hours is highlighted is because that is the minimum amount of time that an LM80 test has to run. And you can see in this case that even out to 10,000 hours at 85 CRI, you're getting essentially 100% light output from where it started. So this information is in addition to the ISTMT, which is a test that we have to do. We have a third-party test, which was actually done at the same time as the photometric test. It stands for in situ temperature measurement test. And they will test the 3 hottest LEDs as well as the driver temperature. And in this case, it ran at 83.1 Celsius for the hottest LED. And we take the LM80 data and the ISTMT data and we plug it into the Energy Star TM21 spreadsheet. So it's a calculator where you put all the LM80 inputs that we saw for, in this case, 55C, 85C, and 105C from 0 hours all the way to 10,000 hours. And we will add the temperature down here for the in situ, which is 81.3, and it will calculate the percentage of down to, you can type in 93. In this case, I've typed in 93 to get the percent light output. And when that's shown in two different ways. So you can either ask for what will the light output be at 50,000 hours, which is 94.56, or in this case, I plugged in 93, and it's saying reported L93 hours is greater than 60,000. And the reason it says greater than 60,000 is that per TM21, you cannot project beyond 6 times your actual measured data. So because we have 10,000 hours of actual data, they will not project beyond that. The first version of this calculator did allow you to do a projected, they have since removed that because it was being misused so often. So we will only project no more than six times the actual tested data. I'm going to hand it back to Zach, and he's going to go through some applications information.
So this product series is obviously geared toward lighting the wall, and as we've often said, the main benefits of lighting the wall would be to enhance the perception of the space, improve its comfort, not having perhaps all just direct sources in the middle of the space, but doing something to treat the perimeter. In the instance of having light-colored walls, getting some benefit in terms of indirect illumination provided from those surfaces. And in many instances, by selecting a feature wall in a space, being able to really focus attention and direct people's movement. On one level, these three products are sort of the intermittent point source version of the style S144. So obviously, if you're using that product elsewhere in a job and you want to keep everything of the same family, it gives you that sort of consistency in terms of look. But the 144 aside, they are intermittent point sources. They are geared toward those designs where you may be looking not to go linear. There might be some other element driving the need to go intermittently. And in this case, you see an example using slot diffusers. Or it may be that that's just the design preference, not to have a continuous linear element, but to use intermittent units. So that's the mindset where this is coming from, along with the notion that it is surface mounted, very shallow in profile at 3 inches, and offers the convenience of not having to get into the ceiling if you have very severe plenum conditions. So as Paul mentioned at the top, you may think of this not only as the point source cousins to the S144, but your alternative to using the S222, 223, and 224, those semi-recessed units, when you simply can't get into the ceiling. A unit like the S-mount, where you can feed it directly with a poke-through, can be very convenient when you're dealing with older architecture, fragile plaster, or once again, just those plenum conditions where it's very difficult to get into, and even a J-box may be an issue. More and more you see monolithic ceiling systems, 4x4 tiles that can be north of 1 inch in thickness, special and unusual grid runners. And while in our past we've certainly done many modified semi-recessed units to work with those ceiling systems, you may just find it more convenient to use a surface-mounted product and do nothing more than a poke-through into an S-mount and call it a day. Often we get presented with curved walls, angled walls, or conditions where the wall just is not orthogonal to the ceiling grid. And while it still means some coordination to get the fixture placement consistent, working with a surface-mounted unit rather than having to cut rectangular openings in the ceiling tile can be a much more convenient and faster way to go. And there are other project situations where you're presented with structural conditions or other elements, and the designer is looking to create a datum line to have the light start that's somewhere below the ceiling. So having the availability of both the pendant and the cantilever mounting accessories allows these three products to deal with those situations. Those of you who have been our agents for any length of time may have the typical question, well, do I follow the same guidelines for setback and spacing that I would have with your traditional sources? And the answer is yes. The optics here were designed to mimic the classic elliptipar performance. So if you know a wall height, we'll typically look for a setback distance of about 1/4 of that dimension. Our longstanding caveat has been typically not closer than 30 inches. If you're much closer than that, it just really becomes difficult to get good top to bottom uniformity and to deal with the next issue, which is the on-center spacing. For a reasonable setback that, again, at least 30 inches or 1/4 of the wall height, we typically look for an on-center spacing that's about 1.5 to 2 times that dimension. And that addresses not only uniformity at the top of the wall, but also to some extent uniformity top to bottom to the bottom of the target surface, because adjacent units do start to contribute to the lower regions of the wall. So controlling that on-center spacing does also impact top to bottom uniformity. As just a what if, here's a room defined as 16 by 20 with a 9-foot ceiling, lighting 2 feature walls. In this case, it's using the smallest 8-inch unit, the S14X, at a 700 milliamp drive current. What you see here pictured would represent about a 0.66 watts per square foot power density. Looking at the 3000 Kelvin 80 CRI for this layout would yield about 28 foot candles average initial on the vertical surface from a 21 watt package, or as Paul rounded down slightly, 20 watts in his earlier presentation. And if you want to try in your mind's eye picture this or compare it to traditional sources you may have used from us, that's akin to a 150 watt halogen, actually quite a bit better than the old 26 watt quad compact fluorescence, and not quite up there with a 35 watt ceramic metal halide, but it would be at least an alternative that you could consider. Now, you may look at the 142 or 143 because the scale of the unit, the longer length, may tie out with something else on the project. But for the most part, you're probably going to scale up in fixture length and consider the 2 longer units as your wall height goes up. So just to demonstrate that, this example is staying with the same 3000 K color temperature 80 CRI, and now looking at a 12-foot wall height, 3-foot setback, 6-foot on center spacing, and that's at 25 foot candles average initial on the vertical surface, is very comparable to our older 250 watt halogens, our single 50 watt long twin tube wall washers, and getting close to a 70 watt ceramic metal halide. And then to take things up one more notch, here you're seeing an 18-foot wall with a 4-foot setback and 8-foot on center spacing. So pushing the on-center spacing to twice the setback. Quite honestly, for this wall height, being back a little bit more would be helpful, but this scenario let me compare to some of our old point-by-point charts in the print catalog, just to show that the 143 is very comparable to a 300 watt halogen. Our double 50 watt long twin tube, or what we used to call the 4X compact fluorescent wall washers, or 70 watt ceramic metal halide wall washer. So that gives you some context to where you might find different scaled walls, the use of each differently scaled products. If you have any questions after the presentation, feel free to contact Paul or myself. We're going to stop sharing the screen and go back on the video so we can show you the physical samples. And I know, Dan, we had a flag that you had raised your hand. There's one question here in the box, which is from you. No wall mount for lighting the ceiling. That question came up when we presented the linear S144. Keep in mind the linear S144 has more mid-power units. For this point source series going to the high power, I would say you could consider it, but you probably want to show your specifier or your client a sample. We just looked at this a couple days ago in a corridor, and where I would say it would fit quite well is, say, a narrow corridor that's 6 feet wide where people aren't always walking at it head on. We looked at it in a 5-foot wide corridor, and even looking at it walking out of a doorway of a conference room and looking at it, it was quite acceptable. Where I might hesitate a little bit is if you're in an 18-foot wide reception area and you have traffic flow where everyone's always looking directly at the lens, then you might think twice. But certainly you could consider that if the situation's right. And if you get a situation and you want us to look at it and comment, feel free to send us some drawings or a photo. Moving on then, we'll point out a few features here on the physical samples because we are a little bit past the bottom of the hour.
Okay. Right now I'm holding up the S141. It's a nominal 8-inch unit. This happens to be our direct conduit feed, so you can see the knockouts on the top. This happens to be a sample, so it won't be normally come with a cord and plug out the end plate. All of these 3 units, the point source units, do come with the end plate, so you don't have to order them separately as you would on the linear product, because when those are run continuously, you really only need to buy 1 set of end plates for the row. These will come with the end plates. There's actually 2 hinges on this assembly. The mounting plate mounts to the ceiling. There's screws in the front, and the whole housing hinges open to access the wiring and the driver. But there's also a hinged lens, and really you should never really have to get in there, except when you want to add a baffle. So you can add an accessory baffle, which will slide right in, and it snaps shut. The 142, just relative size, 16 inches long. This is shown with the baffle, and it's internal, so that makes it easy to mount. This is shown with all the knockouts taken out. This would be an X mount. You would really only remove the middle knockout if you're using a cantilever, and you use the outer 2 knockouts for the 2-stem pendant. And finally, we have the S14X, which is the 21-inch unit. And again, this is for much higher ceilings, and as Zach pointed out, if you were to wall mount this, you would definitely want to mock it up in a situation to evaluate the brightness. But again, you might find that the baffle would give you enough shielding in the lateral shielding for corridors.
And one little subtlety, besides the main optic, there's a secondary diffusion film to provide some softening. If you're going with lens only, that film sits just inside. It's held captive by the form of that extruded lens, but it sits just inside of the outer protective lens to give uniformity to the appearance of that aperture. But if you are going to use it with the baffle, the film moves just inside of the baffle, again being held captive within the extruded lens. But that way the baffle sits outboard of that diffusion lens and shields any brightness you might see from it.
So if you have any questions, feel free to give us a call or email pford@thelightingquotient.com or Zach@thelightingquotient.com. And thank you very much.
Thanks. Just down here.